do'stlar o'ynaylik, hech kim chetda qolmasin. Kelinglar do'stlar o'ynaylik, hech kim chetda qolmasin. Kimning mayli kimda bo'lsa qo'yib bering o'ynasin. Kimning mayli kimda bo'lsa qo'yib bering o'ynasin. Bu yoniga tashlab o'ynasin, bu yoniga tashlab o'ynasin. Bu yoniga tashlab o'ynasin, bu yoniga tashlab o'ynasin. Chachig'i asqalin seni yoniga tashlab o'ynasin. Chachig'i asqalin seni yoniga tashlab o'ynasin. Kelinglar do'stlar o'ynaylik, hech kim chetda qolmasin. Kelinglar do'stlar o'ynaylik, hech kim chetda
Specify procedures of visual script. 2. For the mob assembly machine, we introduce the cartoon charts for the I/O table. Together with I/O table and the cartoon chart, we can edit the visual script easily. To specify procedures of visual script, if only use cartoon charts, maybe we will not understand what's the procedure of the action. We all know the automations is to teach the system a procedure, to teach the action, what a machine can do to handle the assemble in sequence. So we adopt the education Bureau of Republic of China for B class certificate of automation. You can download automation procedure SOP2 from our company's website. You can get 4 files inside the folder. This tool is for English version. As you open this one, you can see assembly, decomposing, drawing of B-class electromechanical integration verification facilities. Number 2, recognition of material quality and automatic filling station. And this one is the decomposing drawing of the number 2, the condition of material quality. The play, the mirror scale, the transport robot, this one, transport robot, the granny filling module, Aquiphone filling and adjustable capacitance sensor. This is number 5, loading and ADD, analog digital converter, and this 7, automatic filling module, 8 automatic outlet conveyor and solenoid valve, numerical valve, interface terminal, and round parts. The one we try to introduce is this one, to teach the user of CMS JPP how to write the procedure of Visual Script. The topic: the condition of material quality and automatic filling station. Sketch of mechanism. We hope the 3D drawings can be shown on the topic to let the cooperator understand what the procedure of Visual Script does. The main mechanism is the index table, controlled by motor-driven index module, and the S3 sensor, orientation sensor. The index table carry a robot. The C vertical lift mechanism. The S5 sensor, S4 sensor. The S4 is top sensor, S5 is down sensor. Can let the robot moving up and down. And the D horizontal elongating mechanism can extend the robot to reach the parts or return back to home position. As extend to cover the parts, a gripper E can be actuated to grip, to hold the parts, lift up and turn and move to next station and putting down, etc. So this is index transfer manipulator is most important in this system. And here is a conveyor, a strap, the metal or non-metal parts on the conveyor. The A dish motor will be running, and the S1 sensor, loading sensor, will sense if there is a component, a parts in position. And the S2 sensor is a material sensor. This one can tell the parts is metal or non-metal, and then report to our system. While the finished parts can be transferred to this slope. This is outlet slope. S18 sensor will sense if there is outlet parts. The robot's original locate in here Suppose this is degree 0, this is plus 90 degrees, this is minus 90 degrees, this is 180 degrees. The home position of the robot is at minus 80 degrees. The input parts to these positions will be sensed, metal or non-metal. The metal parts will be gripped by the robots and turned to these positions and lay down on top of the load meter. The non-metal parts will be transferred to here at the 0 degree position on top of the supporter and waiting for dispensing. After loading and after dispensing, the parts will be moved to the outlet slope. Okay, this is the joint described too. So we can see A. DC motor, B. motor driven index module, C. vertical lift mechanism, D. horizontal elongating mechanism, F. feeding and detracting mechanism, G. dispensing machine, H. blocking mechanism. These A mechanism is driven by PLC's output. We can define A as Y1, B as Y2, etc. Well, you can see S1 loading sensor, S2 material sensor, S3 origin orientation sensor, S4 the top sensor, S5 the button sensor, S6 the left sensor, S7 the right sensor, S8 S9, S10 S11 S12 S13 part sensor, and S14 S18 totally 14 sensors as the input sensor of PLC. So in these drawings you can see the output and the input, the positions, whatever, similar to cartoon charts, but more easily to understand what the machine look like. But most important is here, statement of action. This can differentiate into 4 parts. The first one is machine origin. The second is manual function. The third is most important, automatic function, is what we want to understand and teach CMS CAPP to edit the visual script. Mechanical home origin is the home position of the mechanism. The A, no material on conveyor. No material on conveyor, so the A not turning. This is the home position of the conveyor. The B, index air on at the feed terminal. B is this one. And the feed terminal, what is feed terminal? Is at minus 80 degrees positions. This is the home position of the rover. The B drive will rate the rover at home positions minus 90 degrees. The C, conveyor lift mechanism at the top position. This is vertical lift mechanism at the top position. This is the home positions. The rover at the top positions, then as turning around the tables, won't touch anything in location. Horizontal elongating mechanism D at the back positions. This one, the track back, not extend so long as turning to prevent bump with other mechanism. D at the back position, and filling and titrating mechanism F at the top position, and this one at the top positions, so the rover turning in won't touch the head leader, the leader head or whatever. E, grip opening. The grip opening, waiting for grip the parts. G, dispensing machine, not the titrating. This one not working. H, blocking mechanism to stop feeding of grain. This one is turned out to prevent the falling of the material. Okay, this is the home position, original home position. The menu functions to make sure the capability of control panel can activate each actuator A to Y, A to H, these 8 output. Index operating on condition of vertical lift mechanism at the top position, and a horizontal elongating mechanism at the back position. This means as the turning table turning is on 2 conditions. The first one, the vertical lift mechanism at the top positions, S4 is on, and the D horizontal elongation mechanism is retrieved back. The S6 is on. In these two state conditions, then we can rate the index table turning to different angle, different position. This is the manual functions. In CMS CAPP, we have manual function too, to push each output button to test every output works. And we can see the feedback, the sensor lights as well. This is the testing of manual function. The number 3, automatic function. Putting two kinds of standard material randomly on left of conveyor. Conveyor running. Material sensor differentiating coming parts is metal or non-metal, then handling as following. This means you can put the metal parts or non-metal parts on this terminal. Then the conveyor will running to here before the block. Then the S1 loading sensor will sense there is a component, and then S2 sensor, material sensor, will sense if this one is metal parts or non-metal parts. If metal parts, the mechanism will doing passed by transport manipulator to automatic feeding station, turning 90 degree clockwise after automatic feeding, then to outlet slope. This means if the material sensor sense these parts is metal, the robot at home positions will lower down. The S5 sensor will on, and the horizontal elongating mechanism will be actuated. Is turned to the far distance until S7 on. So these two fingers at both sides of the metal parts. Then the grip will hold the metal parts, and the vertical lift mechanism lift up to force S4 on, and the horizontal elongating mechanism will return back to touch S6 on. The C back to home position and the D back to home positions. Then the model driven index module will turn clockwise 90 degrees to this position. And then the C will lower, the D will extend, and the grip will open, and then back the home position. As the metal parts on top of the low meter, the path sensor S13 will sense the metal parts, and the blocking mechanism will be actuated. This bar will retract back. The feeding materials will falling down inside the metal parts, and the weight, the sensor ADDA will calculate, and from analog information transferred to digital information and the display and the weight display position. Suppose 3 grams is the specified weight. As feeding to 3 grams, the block mechanism will release and block the falling materials to prevent the falling of the material. And the lobar will lower down and extend and grip the filled metal parts, and turning clockwise 90 degrees, and the same lower down and pulling the filled finished metal parts on outlet slope. The sensor S18 will sense this output. While if the material sensor sense this one is non-metal parts, the lobar at home positions will lower down and extend out and grip the non-metal parts, and lift up and it retract back to home positions, and turning counterclockwise 90 degrees to these positions, and then lower down and open the grip to let go the metal parts on top of the supporter, and then the D will retract back the material. The vertical lift mechanism will go up to the home position and waiting there. As sensor S12 sense there is the non-metal parts in positions, the F field and the drilling mechanism will lower down, and the dispensing machine will dispensing into by through of the work drum and the little head, dispensing the liquids inside the content of the non-metal parts. After finished, the lobars will lower down, extend out, and grip the filled non-metal parts, and lift and retract back to home positions, and then the motor driven index module will turn 90 degrees counterclockwise on top of outlet slope and lower down the field, non-metal parts, etc. This is non-metal parts statements passed by transfer the manipulator to feeding and titrating mechanism, turning 90 degrees counterclockwise after automatic dispensing, then to outlet slope. So this is what we hope as a standard procedure by the user using GMS JPP written down for better communication between the mechanism designer and the electric wiring engineer and Visual Script editor and operator, whatever, can communicate by the better descriptions of the mechanism, together with cartoon charts, to form a perfect Visual Script editing system. Okay, ending.